In the constellation Orion, there lies a star that has captivated astronomers for centuries: Betelgeuse. This red supergiant is far larger and more massive than our Sun. But in recent years, Betelgeuse has been acting strangely. It has dimmed significantly and even begun to vibrate violently, leading to speculations that this once vibrant star is on the verge of exploding in a supernova. But what if we're actually witnessing the onset of an even more terrifying event? What if Betelgeuse is not about to explode, but rather about to collapse in on itself? Join us as we explore the latest research on Betelgeuse and its potential implications for our planet. Through this journey, we aim to understand the profound impact Betelgeuse's collapse could have on the future of the universe. Betelgeuse is an enormous star, 950 times larger than our Sun, making it one of the largest stars in the known universe. But with such size comes a cost. Stars like Betelgeuse have limited lifespans, and it is no exception. This cosmic giant is a ticking time bomb, poised to explode, though the exact moment remains a mystery. Situated just 650 light-years away, Betelgeuse has long captivated astronomers, shining as one of our closest stars. We marvel at its brilliance, trying to unravel the secrets hidden within its fiery depths. Remarkably, only 13% of its radiant energy is visible to us. If we could see its full brilliance, Betelgeuse would outshine even Sirius, reigning as the brightest star in our night sky. Imagine a colossal star with a radius 764 times that of our Sun, stretching beyond the asteroid belt, almost touching Jupiter. Within this vast realm, Earth, Mars, Mercury, and Venus would be devoured by Betelgeuse's irresistible cosmic outer. But the mysteries don't end there. Every millennium, Betelgeuse sheds a solar mass, casting off its celestial remnants in a magnificent display of stellar theatrics. A nebula, 250 times larger than the star itself, envelops Betelgeuse, shrouding it in an ethereal haze that captivates our gaze. This nebula, stretching 30 astronomical units, lures us into a cosmic dance of wonder, beckoning us to uncover its secrets. Let's journey deeper into the heart of Betelgeuse's creation, where the alchemy of hydrogen fusion ignites, birthing helium in a cosmic explosion. Over time, the star's hydrogen fuel dwindles, and a celestial metamorphosis ensues. Helium intertwines with carbon, unleashing a radiance that cascades through the cosmos. But even this grand fusion has its limits. As neon merges with iron, an astonishing transformation occurs. The star's gravity, unleashed by the absence of energy release, triggers an imminent collapse, propelling Betelgeuse toward a fate both awe-inspiring and cataclysmic: a supernova explosion. In the realm of cosmic phenomena, supernova reigns supreme, and Betelgeuse is no exception. With the energy of 10 billion suns, this colossal celestial entity unleashes a force that resonates throughout the cosmos, leaving us in awe of its unimaginable might. Throughout the ages, stars undergo a mesmerizing transformation, transitioning from the vibrant blues of youth to the fiery reds of maturity. It was during the 2nd century BC that Chinese stargazers made an intriguing observation, noting Betelgeuse's distinct yellow hue that set it apart from the celestial tapestry. As the centuries unfolded, the baton of observation passed to the keen eyes of Greco-Roman astronomer Ptolemy in the middle of the 2nd century AD. In his meticulous records, he described Betelgeuse as having an orangish or ruddy appearance, a characteristic that still captivates our attention to this day. This consistent coloration across different civilizations, including medieval observers in the Middle East, adds to the intrigue surrounding Betelgeuse. The tale of Betelgeuse takes another twist as we dive deeper into its enigmatic behavior. The star surprised scientists in 2019 when it suddenly dimmed in brightness. Initially, scientists thought that a large cloud of dust released from the star's surface blocked our view of it. However, the origin of this dust cloud remains unclear. Some speculate that a large object, perhaps a planet, might have disturbed the surface of the star, or even been swallowed by it. In recent months, Betelgeuse has become almost 50% brighter than its average brightness. This is unexpected because stars typically become dimmer as they age. Scientists are uncertain about what caused this sudden increase in brightness, though they know that star brightness can change for various reasons. For instance, some stars go through cycles of bright and dim phases. Deep within the heart of Betelgeuse, a seismic shift was occurring. The expulsion of scorching material launched into space created an ethereal dust cloud of magnificent proportions. This celestial dust cloak veiled a significant portion of Betelgeuse's radiant light, transforming it from a dazzling beacon to a subdued luminary in the night sky. Betelgeuse's brightness dipped to levels unimaginable. Once counted among the 10 brightest stars, it now ranked lower than the 20th. In recent months, Betelgeuse has defied all expectations, challenging the norms of stellar behavior. Scientists and stargazers around the globe have been captivated by this mesmerizing cosmic dance. Theories abound, attempting to unravel the enigma of Betelgeuse's extraordinary behavior. Some speculate that massive sunspots or dust clouds are the culprits behind its dramatic fluctuations, while others ponder the possibility of coinciding cycles. Their research exposes the incredible notion that Betelgeuse's supernova explosion may have already occurred. Yes, you heard that right. While conservative estimates projected its supernova event to be hundreds of thousands of years away, the evidence now suggests a different story. The last observed supernova in our galaxy, Kepler's supernova, graced the heavens centuries ago. Could Betelgeuse be the next to light up our night sky in a spectacular display? Or is there something even more extraordinary happening within this giant star? Only time will tell, as we continue to monitor and study Betelgeuse, waiting to uncover the secrets it holds. Researchers have proposed a model suggesting that Betelgeuse is in the late stage of carbon burning, indicating it may be on the brink of a magnificent explosion. This positions it as a strong contender for the next anticipated supernova event in our Milky Way galaxy. Like a grand finale in the cosmic symphony, Betelgeuse stands as a prominent contender for the next stellar supernova within our beloved Milky Way. However, understanding Betelgeuse is like solving a puzzle with conflicting observations. There are indications of material ejections and subsequent recovery, hinting at a mass ejection event, though smaller in scale compared to our Sun. But here's the twist. Supernovae are real phenomena, and we've witnessed one in a satellite galaxy of the Milky Way back in 1987. So while our estimates for Betelgeuse's explosion timing may be uncertain, it's not time to plan a vacation around it just yet. The challenge lies in the current difficulty of observing Betelgeuse. Scientists have studied it for centuries, noting changes in brightness over time, which suggests the star is aging and could go supernova soon. However, there isn't enough evidence to say for sure when this will happen. A supernova is a very bright explosion that occurs when a star dies. Fortunately, it is not harmful to life on Earth, and it is safe to watch with the naked eye. The brightness of a supernova depends on the size of the star that explodes, and since Betelgeuse is a very large star, its supernova would be exceptionally bright, about as bright as a half-moon, visible even during the daytime. The brilliance of a supernova would also pose a challenge for astronomers. The explosion would be so bright that it might make it difficult to observe other stars and planets, complicating the study of the night sky. One possibility is that Betelgeuse swallowed a large object, such as another star, in the past. This could have accelerated the star's evolution, making it more likely to go supernova. A recent paper has discovered something new about Betelgeuse's brightness cycles. It suggests that the longest period, which lasts 2,200 days, could be the main cycle for Betelgeuse's pulsations. If this is true, the star's brightness could change significantly in the future. However, this is still just a hypothesis, and more research is needed to confirm it. Overall, the brightness of a supernova would be a mixed blessing. It would be a beautiful and exciting event to witness, But it would also pose challenges for astronomers and even some animals. What makes Betelgeuse an astronomical gem isn't just its potential to go supernova, but the unique opportunity it presents. This colossal star, with its remarkable size and proximity, grants us the privilege of capturing its essence in breathtaking detail. Unlike distant, twinkling points of light, Betelgeuse reveals itself as a radiant disk through the lens of our telescopes. It invites us to witness its luminous variations, to grasp the subtle dance of its light as it teases us with its hidden secrets. But here's where things get even more fascinating. The supernova display won't vanish quickly. No, it will linger in our night sky for several years, gradually fading away like a distant memory. Yet there may be moments of resurgence, a burst of renewed brilliance before its light softly dissipates, bidding farewell to its place in the constellation Orion. While the supernova poses no threat to us, it may perplex certain creatures who navigate by the moon's gentle glow. With this additional cosmic light, they may find their bearings thrown off, their nocturnal paths slightly altered. But the impact won't be limited to the animal kingdom. Astronomers and stargazers alike will face new challenges in studying our universe. Observing the night sky during moonlit periods can be tricky, and a blazing supernova will only add to the complexity. Yet the allure of this celestial spectacle will draw the attention of countless telescopes and researchers, who will eagerly adapt their observations to capture the magnificence of Betelgeuse's final act. The anticipation is palpable as astronomers and stargazers eagerly await the grand display of Betelgeuse's supernova. The stage is set, and the universe holds its breath in anticipation of this extraordinary event. But what can we expect when this stellar giant unleashes its explosive might? First and foremost, let's put any concerns to rest. Earth is safe from harm. Betelgeuse is situated at a comfortable distance, and while the supernova will undoubtedly captivate our eyes, it won't outshine the moon or the mighty sun. Nevertheless, it will cast its ethereal glow, illuminating our nights and making its presence known during the day for an entire year. Imagine the mesmerizing sight of Betelgeuse's radiant remnants casting gentle shadows upon our world. But this cosmic spectacle isn't just a fleeting moment. Oh no, it's a performance that will unfold over several years. Initially, the supernova will dazzle us with its brilliance, gradually fading into the depths of the night sky. There may be moments when its luminosity reignites, momentarily reclaiming its former glory. However, as time passes, the once familiar star in the Orion constellation will fade away, leaving us with cherished memories of its stellar brilliance. Scientists have found that Betelgeuse's brightness cycles are similar to those observed in stars nearing the end of their lives. This suggests that Betelgeuse could go supernova soon. If it does, it would be the nearest supernova to Earth in centuries, visible to the naked eye, and exceptionally bright. However, it's important to note that this is still just a hypothesis, and more research is needed to confirm that Betelgeuse is indeed on the verge of a supernova. Even if Betelgeuse goes supernova, it is unlikely to be dangerous to Earth. The star is about 550 light-years away, so the explosion would not be as powerful as a supernova closer to us. The first sign of Betelgeuse's impending supernova would be a burst of neutrinos, tiny particles that pass through matter without interacting, so they wouldn't pose any danger to us. After this neutrino burst, we would witness an extraordinarily bright object in the night sky, as bright as a full moon, visible even during the day. This intense brightness would last for several weeks before gradually fading away. The explosion would also release a vast amount of dust and gas into space, which could block some light from other stars and cause short-term changes in Earth's climate. However, these effects would likely be minor. While this celestial event won't pose any direct threat, it could perplex animals that rely on moonlight for navigation. Amidst this grand cosmic performance, astronomers would face their own set of challenges. Observing the night sky is already a delicate endeavor, particularly during a full moon. A supernova of such significant brightness would complicate matters even further. Yet the allure of capturing this celestial spectacle surpasses any obstacles that may arise. Scientists will adjust their telescopes, fine-tune their instruments, and seize every opportunity to witness and document the evolving beauty of Betelgeuse's supernova. Although the James Webb Space Telescope may not be able to directly observe Betelgeuse due to its overwhelming brightness, a network of observatories on Earth and in space eagerly awaits this momentous event. Armed with cutting-edge instruments and techniques, they are poised to uncover the mysteries hidden within this celestial fireworks display. Together, these observatories form a global alliance, united by their passion for unraveling the secrets of the universe. However, Betelgeuse has shown that it can be unpredictable. In mid-February 2020, its brightness stabilized and remained constant for over 10 days, leading some to believe that the dimming event had concluded. But 5 days later, the star ceased its dimming altogether, confounding astronomers and leaving them intrigued by its unpredictable nature. This puzzling twist in the cosmic narrative kept scientists on the edge of their seats. In their quest for answers, a study conducted on February 24, 2020, shed light on the possible causes of Betelgeuse's enigmatic fading. It was revealed that the star's dimming was likely due to large-grained circumstellar dust obstructing its radiance. This cosmic veil of dust cast shadows upon the star's brilliance, adding to the mystique of its cosmic performance. Advanced measurements at sub-millimeter wavelengths dismissed the idea that dust absorption was the main factor behind the dimming. Instead, scientists suggested that massive star spots, vast regions of turbulent activity on the star's surface, akin to sunspots on a grand scale, could be driving Betelgeuse's fading. These star spots, along with the presence of a cold spot on Betelgeuse's photosphere, introduced a captivating element to the unfolding cosmic drama. As the dust was believed to be born from the star itself, cooling and coalescing into delicate particles, it painted a transient masterpiece in the heavens. In a symphony of scientific discourse, the initial hypotheses gained strength and clarity, bringing us closer to understanding Betelgeuse's mysteries. The scientific community has made great strides in understanding the universe. Thanks to technological advancements, the Hubble Space Telescope has helped scientists study mysterious cosmic bodies, while the James Webb Space Telescope has revolutionized our understanding of black holes, dark energy, and the fate of stars. In 2022, their gaze pierced the veil of uncertainty, revealing an awe-inspiring spectacle, a surface mass ejection from Betelgeuse. Like a stellar phoenix rising from the depths, Betelgeuse unleashed a torrent of material, shedding its luminous skin. This expelled matter, cooling and condensing over vast distances, gave birth to the ephemeral dust that now veils the star's resplendence from our earthly observatories. The fading of Betelgeuse has finally ceased, allowing the star to reclaim its position among the brightest luminaries of the night sky. Its brilliance, shining 100,000 times brighter than our sun, stands as a testament to its stellar grandeur, despite its vast distance. But such brilliance comes at a price, a fleeting existence fueled by the rapid consumption of energy. Betelgeuse's inevitable fate looms: a depletion of fuel, a collapse under its immense weight, and a cataclysmic explosion, an awe-inspiring supernova. For a brief period, Betelgeuse will blaze with unprecedented radiance, rivaling the brilliance of a full moon, both day and night. Its brilliance will captivate the hearts and minds of observers across the globe. As Betelgeuse approaches the end of its lifespan, the possibility of a supernova event looms on the horizon, although the timing of this cosmic spectacle remains a subject of intense debate. Betelgeuse exhibits 2 cycles of dimming and brightening, with the second cycle occurring every 5 years and lasting approximately 100 days. During this cycle, the star's outer shell expands and contracts, causing fluctuations in its diameter and average temperature. Betelgeuse was expelled from its original position in the Orion OB1 association, which encompasses the stars in Orion's belt. It is currently observed moving through the interstellar medium at a staggering speed of 30 kilometers per second. This rapid motion creates a bow shock that spans over 4 light-years. Determining the precise distance to red supergiant stars like Betelgeuse poses a challenge in astronomy. The star's actual diameter has proven difficult to ascertain due to various factors. As a pulsating star, Betelgeuse experiences fluctuations in diameter over time. Additionally, its optical emissions change color and diminish as they move away from the center, making it challenging to define a distinct edge for the star. The presence of the circumstellar envelope, composed of expelled material that emits and absorbs light, further complicates the task of defining Betelgeuse's photosphere. These intriguing findings shed light on the aging and mass loss of red stars, ultimately leading to their explosive transformation into supernovae when their nuclear fusion fuel depletes. Betelgeuse's unusual behavior doesn't necessarily indicate imminent fame. A significant mass loss event doesn't always foreshadow an explosion. Experts reveal that a massive surface ejection from a giant star has never been observed before, and we have the exciting opportunity to witness and study this phenomenon firsthand using the Hubble and Webb telescopes. Betelgeuse's fading has ceased, potentially reclaiming its position as the 10th brightest star in the sky, shining 100,000 times brighter than the Sun, despite its distance. However, the immense energy demands hasten its eventual demise as it exhausts its fuel and collapses, leading to a brilliant supernova explosion. For a few weeks or months, Betelgeuse will illuminate the sky, rivaling the brightness of a full moon. While the timing remains uncertain, Earth is safe from any harm, as the Betelgeuse supernova will occur over 10 times farther away than the distance required for a supernova to be deadly to humans. But we still don't know when this spectacle will happen. It could be in our lifetime, or millions of years from now, and not even the smartest astronomers have been able to accurately predict when this moment could likely be. Thanks for watching another episode of Astral Voyager. If you enjoyed this deep dive into the mysteries of Betelgeuse and the cosmic wonders that surround us, be sure to hit the like button and subscribe for more stellar content. And while you're still here, don't forget to check out the next video on your screen for more fascinating insights into the universe. Keep exploring, keep wondering, and stay curious. See you in the next adventure.